All right, let's get to this. You guys should not take too long on this. All we've been doing for the last day, maybe two, is graphing inequalities. So you guys are already familiar with the whole solid line, dotted line, which side to shade. That's going to expedite this lesson tremendously. So what we're going to do today is what the 12th, and starting today, we are going to be graphing systems of inequalities. And really, if I were a true professional, I would have written systems of linear inequalities, but it's okay. We'll let this one slide. So all the stuff you've been working on for the last couple of days, we're just going to put it into a package and do two of them at the same time. And so I'll walk you right through the process. I have four examples. That's why there's four graphs on that piece of paper that I gave you. So for our first example, we're going to do y is greater than negative 4/3 of x plus 3. And we're going to do y is greater than or equal to 2/3 of x minus 3. Obviously, what we like and appreciate about this problem is the fact that y is already by itself. That saves us a ton of time. And by a ton, I mean like 30 seconds. But still, hey, that's time. So let's talk red first. Where would we start the red graph? Nice. Thank you for saying up, not positive 3. I appreciate you. Up 3 is perfect. And where would I go to make the slope happen? Down 4. Perfect. Down 4, right 3. You guys are saying all the right words. 1, 2, 3, 4. 2, 3. 1, 2, 3, 4. 1, 2, 3. Make sure you have points far apart. 2, 3, 4. Oops. I think it's right there. I wish that would. Let me see if I can just move this. There we go. All right. Are we going to make a solid line or a dotted line? Okay, so you guys have the advantage here. You guys can just make the dotted line as you go. I have to, as you know, from watching me clumsy around on this, I've got to make it and then go. This is what you would do on a test. If you forgot to make it dotted, you would just do what I'm doing. You'd just turn your pencil over. Some people like, oh, God, I got to graph the line over again. And it's like, no, you don't. Just erase some chunks. You're good to go. Are we going to shade above or below? Now, what I want you to do is not shade. Don't shade. I'm going to show you today that when we double shade, it starts to get a little bit messy. So what we're going to do instead is we're going to just draw some little arrows of indication like this. Just 4, 5, 3, whatever. Just put enough arrows so that you remember where the shading would go. And you'll see here in a moment why we do it this way. Now we're going to start the green one. And so where would I start the green line at? Down. Down 3. Very good. So I'm going to go down 1, 2, 3. And what's the slope of that line? Down 2, right 3. No, it's positive. So we're going to go up 2, right 3. I would be okay if you went down 2 and then, of course, left 3, provided that, you have to turn left because we want to make sure that the line tilts in a positive direction. Is this line going to be a solid or a dotted? Yeah, this one will be solid. So I don't have to fudge this one, which is nice. Here. The same rules always apply. These are just habits that we just, we don't even ask. Like, if someone, should I put lines on these? The answer is always going to be, yeah, of course you should. So just do it. Eventually, it's just a habit and you just do it kind of without thinking about it. Which way would we shade relative to the green line? Above, because it says is greater than. So what we're going to do now is we're going to make an observation. And the observation goes a little something like this. If you want this lesson to make sense, now is a great time to pay attention so that this all comes together. In order for a system to work, you've seen this with systems of equations, is that to be a solution of a system, everybody has to be happy. So like if I put a purple X or follow the purple dot, if I put a point right there, is that a solution? It is not. And I understand why you'd say yes, because I get it. Like it's above the green line. But remember what I just said is to be a solution, everybody has to be happy. Am I above the green line? Yeah. Am I above the red line? Then I'm not a solution. So what we understand about this now is that I've done this in the past. I've tried it all sorts of different ways. I've tried shading and more shading, and then the answer is like wherever the shading is darker. What I've learned over the years is this is really just the cleanest way to go. That purple dot is not a solution. This purple dot is not a solution. This purple dot is obviously not a solution. All of the points that are up in here are the solutions because they, as dots, can say, I got this. I'm above the red line and I'm above the green line. So our shading should look like this. This is how you graph a system of inequalities, is you do multiple of them and then you indicate where the shadings would go, and then you only shade where all of the shadings would essentially overlap with each other. Are you done? Goodness gracious. Unwrapping candies, carrying on. Any questions about that? All right, let's do another one. Next one. Let's do y is less than 3 and y is less than or equal to negative 5/3 of x minus 2. So again, we like this. This won't be the case for the third and fourth. We only have 4 examples today. First two, I tried to make them easy. Second two are going to be a little bit harder. So the top line, what is that?
It's a horizontal line.
It is very good, Keith. It's a horizontal line. And so I'm going to go up here to 3, 1, 2, 3, and I'm going to graph a boundary going sideways. Solid or dotted boundary? Dotted. So I have to fudge mine. You can just do it right the first time, and you don't have to fudge. So I grab my eraser and I take out chunks of it like this. And again, don't shade, just draw indication arrows. Where would the shading go if we were going to? Underneath it, below, because that's where numbers get less than, of course, is when we go downwards. Good. So our indication arrows are in place. Let's do the other one. Where would we start the second graph at? Down 2. Very good. And what's its slope? Good. 1, 2, 3, 4, 5. 1, 2, 3. And since I want more points and I'm out of space, I'm going to go and back up and reverse it and go up 5 and back to the left 3. You can get, as you know, we've done this before, you can get as creative as you want, provided that your slope remains proportionally accurate. It's got to have 5 rises for every 3 runs, and it's got to go downhill. Them's the rules. Solid or dotted?
Oh,
Nice. Oops, I keep forgetting to grab my straight edge, so do that. Get it moved into position a little better. And of course, I'm forgetting my arrowheads. And where would the shading go if we were going to do it? Under. Good. And remember, there is no left or right. If you talk in those terms, this will be a real disastrous unit for you. So there's above and below. And the only exception would be if it were vertical. So to be below the green line means this direction. And then we simply ask ourselves, where would the red shading and the green shading collide? And you should be able to see with a lot of clarity that there's a corner right there. I've purpled it for you. That corner is where we sort of have to turn to stay following the rules, right? That's the corner where I turn and say I'm still below the red, but oh, I got to turn now to stay below the green. And so the shading is simply just at that. And so you can get as artistic with this as you want. I will say that I've got no issues if you're more of an artistic person and you like to use like colored pencils. Some people use like a light shading of red and then a light shading of green. And I don't know, what do you get when you cross red and green?
brown.
Like vomit brown colored something. So some people like to do it that way. It's not a criminal offense to have some lighter shadings and then a darker area that everyone knows is the answer. I just prefer this. I think this looks nicer. So that's the way I teach it, and that's the way I do it. If I had like semi-transparency kind of pens, maybe I'll try the next one with a highlighter. I think I have highlighters and you can see if you like that. But anyways, for our third example, I'm going to make you do some math. So for this one, we're going to do 4x minus 3y is less than or equal to -9. And then above that, I meant to write this one first. I'm going to do x is less than 3. What kind of line is that top one?
That's the vertical line.
That's my vertical. So I'm just going to kind of leave that one there. I'll sit that one on the back burner for a while. We got to go tackle the bottom one. And of course, the mission for the 988th time this year is to get y by itself. So how are we going to start getting y by itself?
We're gonna divide.
Hmm.
No, we're gonna move y.
Hmm.
Switch it y and x over.
There's no 4.
Or 4.
There is a 4x. That I will accept. We should instinctively just be saying to ourselves, -3y, sit, stay. Don't move. Maybe you give it a little treat to munch on while you're going to do some work. We love Y on the left-hand side. And if that's where he is, we say sit, stay. I'll be right back. I'm going to pick up this 4x and trash it to the other side. So the -3y, as a good little term should, sat and stayed. And what is my right side going to say?
No.
Nice. Now I'm ready to hear the diviso whatever word. What is that?
-3.
Time for division, right? So now we're going to take and divide by -3. We're going to divide by -3, and we're going to divide by -3. This is officially the danger zone. This is where I pray and I hope. All I can do is sit back and just and cross my fingers and just hope that they're like fly, birdies fly. In a perfect world, every one of us would remember what we have to do. What is it? We have to switch the sign. Correct. Because we divided by a negative, the less than sign becomes a greater than sign. That's important because in a moment we're going to make a decision about shading. And if we base our decision on that sign, we want that sign to be going the right way. What's our slope going to be? Positive 4/3. And what's our y-intercept going to be? Positive 3. Good. So everything now, I don't want you to do what I'm about to do. I'm just, since I'm teaching this class, I kind of want to have a cleaner workspace. So I love your work. I'm just getting rid of mine. These are the things now that we have to graph. So let's start with the top one. X is less than 3. You said it's a vertical line. So I'm going to go to 3 on the x-axis and graph a vertical line like this. I love horizontal and vertical lines. They're so easy and like relaxing. It's dotted, so I need to do a little fudging. Which way will I shade? Which way would I shade? To the left, of course, because less than to anyone would mean to go to the left. So far we've got this potential shaded zone. And now we have to graph the other line. Where will we start the second line? Up 3. And what's his slope?
Up 4.
Up 4 what?
Right 3.
Good. So up 1, 2, 3, 4, 1, 2, 3. And then the other way, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. You don't have to graph every point along the way. You just have to make sure you have a couple that are at least a couple miles apart so that your line connects with every point in between. That's the key. Solid or dotted?
Solid.
I like it when they're solid. You probably do too. Maybe you don't. I don't know. All right. Where would the shading go off of this? Off the green line, where would the shading go? Above. Thank you. That's what I'm looking for. Remember, we do not say left or right. That would only come up if we were talking about a vertical line. So now what I have to envision is that if I'm going to be pushed left of the red line while also being pushed above the green line, we should all identify that there's something significant happening right here. right at that purple corner is the key. Because I'm left of red guy, I'm above greeny, and then I'm just going to go a little bit ham with my pencil here, establish a boundary, and then just go nuts. Bam, bam, bam. That's all you got to do. Oops, I fudged a little bit. I went over the. Uh-oh. I'm gonna fix that. It's a close call. Any questions so far? Good. All right, last one, okay, guys, and then it's work time. I got an assignment for you. I thought I'd write them like this so I can have a little more room to work. All right, they're both in the categories since Y isn't by itself. Bless you. Pretty standard approach to the top one. Once you get really good at algebra, you wouldn't do what I'm about to do. But I kind of like the sweet zone that we're in this last little while. So we're all going to do the robot move. We're going to add or move the X to the other side. So we're going to keep the negative Y over here. We're not going to change the sign. You never do if you move something. What's my right side going to say? Negative X plus 2. Very good. That one is ready to go. So that one I can transport up here and say sit. I'll be, boop, that one's not ready to go. What's wrong with me? It's not ready. There's a negative, like I've never done this before. Let's divide everything by -1. There you go. Jeez Louise, what a slacker. So what do we get for our final answer? Y is what?
One is greater than or equal to x plus two.
X minus 2. Because it was a plus 2 and we divided it by -1, of course, right? So I can now look at this. Now I'm not wrong. If I do this, I can say you're ready to go. Getting all this? For the next one, same approach. It's actually almost an identical problem. We're going to move bless you, we're going to move the 5x to the other side, which is going to give us negative y is greater than or equal to what? Nice. And then we're going to do that thing we do when we have those pesky negatives that just leech onto our y. Now, we've come to work with them, but that doesn't make them any less annoying. So we still now have to divide by -1. Some people just call that dividing by a negative. Same, same. All right, it's the moment of truth. We get y, and what do we get on the after this? Y is less than. We switch the sign. Nice job. And what's our right side going to say? So again, that's the math part that just it can't be something that we're still in the process of understanding. That should be a skill that we all now possess by February 12th. Time to graph. Let's graph this first one, the one with the red check mark. Where do we go?
We go to the origin.
We go to down 2. And then what is the slope?
Up one again.
Up 1, right 1. So I'm just going to keep going. I'm going to go in a diagonal because I don't want to make a bunch of dots. So I'm just going to go way out here and make one. And then I'm going to go way down here and make another one because that's fine. As long as they're far apart. Doesn't matter. Solid or dotted? Nice. So I don't have to do my little fudging thing. Good. Where would the shading go if we were going to do it? It is greater than or equal to, therefore we would go above. Because remember, after we divided by that -1, we had to switch our sign. If you don't want to base your decision on the sign, then you have to go back and do the old school plugging in 0 and 0 thing, which is fine. I like it this way. How about the next one, the second line? What's it going to start at?
2.
Slope.
Up 5, down.
Like this. Solid or dotted?
Oh, oh.
Nice. Love it. Arrowheads on there. Where would the shading go?
No, only.
It says less than, so we're going to go under. And again, if you're someone who sees this line, this green line, I don't know who I'm talking to. I never know until I get a chance to see it. And sometimes it's too late. If you're someone who sees that as the right side and the left side, this chapter is going to kill you. You cannot see it that way. It has to be like this up here is the top side, this down here is the bottom side. Okay. So make sure you think in the right terms. We do go below, which in this case looks like this. And where the green arrows and the red arrows would come together is, of course, right in this little corner is where we sort of bend off to make everybody happy. So that's it. Do you guys have any questions about how to graph a system of inequality? Nothing? All right, I will pause the old recording and I'll hand out your paper. And if this is the end of the recording, then that means no one had any questions. Um, so for the first equation or inequality, I'm going to assume you started at up to.
Yeah.
I'm going to assume also, since I yelled at you for this a lot yesterday, that you did not have a line that went uphill, but rather that your line goes downhill like this.
Yeah.
Okay, thank goodness. Because I really don't want to yell at you anymore for this mistake. So, because the slope is negative, so the tilting direction has to go like this. And because it says y is less than or equal to negative x plus 2, then we're going to leave it as a solid line like this. So far, so good. Where would the shading go if we were going to make full shading at this point? It would not. This is a less than sign. And the only way, when we talk about verticality, the only way for something to get less than is to shrink. And shrinking means to like go down, get lower. And so because it's a less than sign, the shading would be pointed in the direction of these little arrows below the line. So far, so good.
Yeah.
Our next inequality is y is less than negative 4x minus 1. Are you caught up and ready to move on? Okay, so where would we or where did you maybe start this one? Good job. And then the slope is what? Talk me through it. I'll take it up 4, left 1, or conversely down 4, right 1, like this. Is this line going to be solid or dotted?
No.
Okay, so I'm going to make a line and then I'll go back and fix it. Where would the shading go since it says less than? Bottom. And the bottom is anything tilted. What I know, I get that it feels like we're saying to the left, but it is the bottom, right? And so what we have to do is say, where do those shadings overlap each other? And the overlapping occurs here where there's like a bend in the road right there. Did you see it?
Yeah.
That's where we get caught up and say, I'm going to stay below the red, but now I got a new green that I got to kind of get a little sharper, got to turn a little sharper. So our boundary should look like this, and then your shading is just all this stuff in here. Got it?
Yeah. So.
Yeah, it was weird on that first one that you said above, but are you good on less thans and greater thans, like which is which?
Yeah.
Okay. Little brain fart maybe? Less thans below, greater thans above. Cool.